This is Chapter 8, Lecture number 4. It's our last major concept. It's dealing with the words polar and nonpolar, and how they relate to a bond and to a molecule. When we talk about a polar or nonpolar bond, we're talking about within a molecule. These covalent bonds, the dashes that we've been using to show the shared pair, differ in how the bonded atoms share the electrons. So the first type is called a nonpolar covalent bond. The covalent part is the sharing. A nonpolar bond is the bond that is formed when the electrons are shared equally. This is the 7H club. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and then the seventh one is iodine. If we were to draw the Lewis structure for hydrogen, it would be an H single bonded to an H. Because it's the same atom on each side, the electrons are pulled equally between the two. The electronegativity difference is 0, and it's called a nonpolar bond. Nonpolar, no poles. It is shared equally. Nitrogen we should know now as a triple bond. And oxygen we should know as a double bond. But the electrons are still pulled equally in the bonds between the two atoms with the same strength. If the electronegativity difference is greater than 1.7, we have an ionic bond, and if it's something between the two, we have what's called a polar bond. So now we're going to look at a polar covalent bond. Again, covalent means sharing, but now polar means that the electron pair is not shared equally. It's the bond that is formed when the atoms in a bond pull unequally on the shared electrons. The more electronegative atom will have the stronger attraction, and that side of the molecule gets a slightly negative charge. So here's HCl. Chlorine has an electronegativity of 3.2. Hydrogen, 2.2. So essentially the difference is this. So we are in the polar covalent region of electronegativity difference. Because chlorine has a higher electronegativity, it pulls the electron pair closer to it, and it ends up having a slight negative charge. Where the electrons are pulled away from, we end up with a slight positive charge. So the electron pair is pulled closer to the chlorine. And since electrons are negatively charged, we end up with a negative side to the molecule. We can draw water. And water has a lot of different shapes that they use to draw it. If we look at this one, because oxygen has a higher electronegativity, it ends up having negative charge closer to it. Since the electrons are pulled away from the hydrogen, it ends up with a slight positive side. This is why it's a polar molecule. It has charged ends because of the unequal distribution of electrons. So that's the first way the word polar and nonpolar are used, and that's within the bond. But there's another way they use the word polar and nonpolar, and that's in the shape of the molecule, the overall look of the molecule. The presence of a polar bond makes the entire molecule polar. Usually, in a polar molecule, One end is slightly negative, it has a pole, and the other end is slightly positive, it has a pole. A molecule that has two poles we call a dipolar molecule, or simply a dipole. A polar molecule is asymmetrical, so it looks different. And to do this, we usually draw crosshairs. What kind of a molecule is HCl? Well, if we were to draw the crosshairs, it is not the same from side to side. It looks the same from top to bottom, but both conditions have to be met. So this is a polar molecule. Water. If we do the crosshairs, it is not the same side to side, and it's not the same top to bottom. It is a polar molecule. Ammonia is a polar molecule. We drew NO2 ion. Remember, everything needs 8. It is polar because it is asymmetrical. And this is methanol. And it is polar because it is asymmetrical. It is not the same side to side and top to bottom. We also have what are called non-polar molecules. A non-polar molecule is a molecule that is symmetrical. Now, it could have polar bonds or non-polar bonds, but there's symmetry. Non-polar molecules are usually in the gas phase, which we'll discuss later. So examples of non-polar molecules. Hydrogen, any diatomic, is non-polar. It's the same side to side, and it's the same top to bottom. So oxygen with its double bond. And again, we're just looking at the general symmetry, not how the electrons look. Nitrogen, again, another diatomic with a triple bond. Ethine, now this is a polar bond because carbon and hydrogen are different. This is a nonpolar bond because carbon and carbon are the same. And this is a polar bond because carbon and hydrogen are different. But the molecule overall, it's the same side to side, and it's the same top to bottom. So it is a nonpolar molecule. Methane is nonpolar, even though it has polar bonds. And carbon dioxide is nonpolar, even though it has polar bonds, because it has symmetry. So we're going to discuss this more in detail in class, and that will be it for this lecture. Just keep in mind, this is the last of the hard stuff. So if you can draw ionic and covalent compounds, and you can now recognize a polar and nonpolar molecule, then everything should be pretty much set for you to do well on the test. So we'll talk to you later.